Hey everybody, this is day 10, which is Tuesday. So what I have done is I have made a little bit of changes onto your assignment board, if you want to call it that now. So what I'm doing is I'm having you have a requirement where you do the reading assignment, you do the one-pager, and you do the math problems that I assign you. The other ones are additional resources, and what those are links to things that are online for you to get. So make sure that you access that, and make sure that if you're having a problem with something, then just go ahead and use that to help. And I've decided to start a timer that way that my videos are not going to be too long where I can't put it on YouTube. So additional problems or additional help is online for you. Like I said there, for the you don't have to watch my video if you don't want to, but then I might have it required for you. And if it is because something's wrong with your work that you send me, then you need to look on here, just go and make corrections, okay? And I can see who sees and who's on here and who's not. So let's go ahead and go over this handout. So the first thing that I want to talk about is my one-pager. So this is talking about torque and simple machine. It's distinguishing between torque and force. First of all, the center of a mass of an object is not always the center of that object itself. So what we're talking about there is there might be something that you're using. For example, you're tossing something up, and that center might not be the exact center of that object. Okay. Also, in the book, it talked about a cat. So in this section, it's going to be talking about a cat, and it's talking about them going in and out of a door. Okay. So what they're doing there is they're saying that here's the hinges, and the cat's going out the door. So what's happening here is the cat is actually pushing its way out. So cat pushing on the bottom of the edge, force is perpendicular to the door. Now what I've done this time is I've been putting my definitions in purple, and I am using pink or underlining for any of the variables this time. So we have what is called a lever arm. And we also have what torque is. Torque is the ability for the force to rotate on an object around some axis. The lever arm is perpendicular for AX is the rotating of the line drawn along the direction of the force. D here, and now just drew the picture that was in the book, is talking about its perpendicular distance from the axis rotation to the line applied force. And then it gave you 3 scenarios. And those 3 scenarios is a cat going through the door and what's happening with that. Now, I want to make sure that you understand torque has a symbol of tau, T-A-U, and that is a weird-looking T. Magnitude of torque is where you're going to go here, and you're going to take your force and displacement times your sin and your angle. So that's force times the lever arm. And then also SI units are in newtons per meter. And then distance is from the axis of rotation to the point of where the force is applied. And then also sine of torque is vector quality. So want to make sure that you understand some other important facts. Number 1, clockwise position is positive and counterclockwise is negative. And here is our equation. T net equals the sum of the torque. You have torque 1 plus torque 2. Force 1, D1 plus negative force 2, D2. Okay? So the first one gives us a problem. It says a basketball is being pushed for 2 players during tip-off. One player exerts an upward force of 15 newtons, and he has a perpendicular distance of 14 centimeters, which I changed to 0.14 on the axis of rotation. The second player applied a force of 11 newtons, and there's my force there. And then the perpendicular distance is 7.0 centimeters, which I also had to change to meters. So then I want to make sure that I understand. When I'm doing these problems, I have to have meters, and that has to be converted when I'm doing my problem. So it's giving us the formula that we're going to use, which is T net T1 plus T2, F1 D1 plus FD2. And so what they're doing is they're trying to find for T net. To be able to do that, they took 11 from 7.70 meters, which gave me that number. This is for 2.1, excuse me, and then I'm just subtracting those, and I get 2.9 meters, newtons times meters. So let's go back to the practice problems as quick as we can. So the first one says, find the magnitude of the torque produced by 3 meters. Okay, 3 newtons of force. So 3 newtons of force applied to the door at a perpendicular distance of 0.25 and on its hinge. Well, if I'm looking at something on its hinge, that's going to be a 90-degree angle. So let's see if we can do this. So the first thing we want to do is turn our calculator on. We want to go to our mode, and we want to make sure that we are going to be in degrees because we're working with angles here, right? So we're going to do, let me move this over so you can see it, and I think I'll move this over so you can see it better. There we go. So then what I'm going to do is open bracket 3.0, close bracket, open bracket 0.25, close bracket, open, no open bracket there, so I'm going to delete that, and then I'm going to do my sine, which is my second, 90, and then enter, and then I get 7.5 times negative 1. Well, I don't want it being scientific, so I want to go here and change it to normal, and that gives me 0.75. So on here, I'm going to put down that I have to change mine to degrees in normal mode, so I'll know. Okay, number 2 says, the number 2 says a simple pendulum consists of 3.0 kilograms and point mass hanging for 2 meters. The long string is connected to the pivot point. Calculate the magnitude of torque due to gravity force. My gravity is always 9.81. With the string attached to a 5%. No, it says make a 5-degree angle. So let's go over here and let's see what we did here. So here we are going to go through and we're going to put for our torque. So that's 3.0, 9.81, because I'm timesing this, right, by this, and then I'm going to times it also by 2.0, because that is my distance, right? I got to have gravity in here also, which is right here. So since I have gravity, I'm going to do mass times gravity times distance, and then I'm going to do my sine, and that is 5.0, close bracket, enter, 5.1, and so on, and I changed it to 5.1 newtons per meter. So we're all good. B asks us for repeat the calculation with the angle of 15. So the only thing I'm going to do now is I'm going to change my angle to 15. So I just plug that in just like I had before, and you know what I'm going to do? I'm going to do second answer, enter. Well, excuse me. I'm going to go back up and I'm going to go in to my number, and I'm just going to go over here and I'm going to change this to 15. And then my answer is 15 newtons. All right. So number 3, if the torque required to loosen a nut on a wheel of a car and has a magnitude of 40 newtons per meter, what is the minimum force must be exerted on the machine at the end of a 30-centimeter wrench that's loosened the nuts? So here on my paper, as you can tell here, I'm actually using the numbers that's provided. And so I'm taking my 40 newtons. So it's a fraction, so I'm going to do alpha y enter, right? And so that is going to give me 40.0 over 0.300. I need to delete that and hit enter, and that gives me my answer there. Also on there you have a choice board, and it's not really a choice board anymore. Now it's options. There is one on there talking about interactive review. That's what I have here. And, maybe it'll help you. So if you have any questions, please reach out and have a good day.